Yeah, so look at the Unit 3 schedule. This unit, polynomial, we have total of 9 days on it. So we have one quiz and one unit test. We have some disruptions, like October 12th, that's Wednesday. You guys are going to take the PSAT, well, some of you going to the museum. So it's only a 30-minute class. In the morning is PSAT. So we're going to use 2 lessons to do this, okay? Your first quiz, just take a quick look, is going to cover 4.1 to 4.7. That's the first 2 days lesson. 4.8 we're going to teach, but not included on the quiz. And on October 27th, this is A day, right? That's the field day. So 30 minutes class, we're just going to call it the vacay day. You're not going to be able to focus. We do some work, but not much. That's why the second review day is going to do B day, A day first. So this time the unit test, we will start with the B day. So after B day. Yeah. So that is, you have quite a lot of day off in October. Like Parent Teachers Day are 2 days.
When's Parent Teachers
Day? Is 28th and 31st. Here's the October breaks and Teachers PD Day. All right, great. Sorry. Right? Yeah. All right, so if I can get you to open today's lesson, we have quite a lot to go over. 4.1 to 4.4.
Why is it like 3-4?
Why is it like what?
It's like 4 lessons and 1 lesson.
It's all fairly easy. They break it down really like fine, so don't worry, you're gonna get this. Okay, ready to go? Ready to roll? So the topic is called polynomial. Did you learn some word that's poly, start with a poly? What did you learn before? Math related, start with a poly. Polygon, that's right. What does poly mean? Many. Polynomial? Nomial means term. So many terms add together. So polynomial. So today we are going to learn the definition of polynomial. What kind of math term we will define as polynomial. Not all terms are polynomial, okay? And how do we add, subtract, multiply, and divide polynomials? How do we factor? So this unit is really crucial. It's a lot of factoring. And factoring is the foundation of your future math. If you mess up this lesson, foundation is very shaky. So I suggest you do really, really well. So, without further ado, you guys already familiar with variables and exponent, right? Variable could be any letter, could be x, y, everybody familiar with, could be a, b, or v, or t. Exponent is you bring something to the power, so 3 to the power of 2, that is exponent. Okay, x to the power 2. That number is the exponent of the term. So things like 3 times x power 4 or 6x, you have dealt with that before, right? So polynomial are sums of these variables and exponents. Each piece of the polynomial we can add them. So we can add the term together. So, for example, we can add x squared minus 2x plus 3. So there are 3 terms in this polynomial expression. So we are talking about a number multiplied by variable to the exponent, but there are some restrictions. So that exponent has to be positive integer. Integer cannot be fraction, right? Because it's positive, so cannot be negative. Those kind of exponent is not qualified to call themselves the polynomial family. They are different family, okay? Don't get confused. So, no fraction power, no variable in the denominator, okay? Or any fractions. What does that mean? Negative power, have you learned what is the meaning of negative power? X to the power of negative 6 can be written as what? What is 3 to the power of negative 1 mean? 1 over 3. You remember that? When you have negative power, you can bring down to the denominator to become positive power. So really, this is the coefficient 6 divided by x squared. That is equivalent. So we cannot have the variable in the denominator, and the negative power will cause that to happen. So that is not polynomial. Okay, so look at that. That is also not polynomial. Variable in the denominator. If you write it in x to the exponent, that will be x to the power of negative 2. Square root of x. Can you write it in the exponential form? So square root of x is x to the power of what? Anybody remember this? Did you learn this? X to the square root. One half. Did you learn this before? No? Okay, so now you know. Square root, you can write as x to the power 1/2. If you have x to the power 1/3, that means it is cubic root of x. Okay? If you have x to the power of 2 over 3, in the denominator is the root, so cubic root x to the power of 2. Okay, that's how you convert radical form to exponential form. All right, the last one. Finally, does this qualify to be polynomial? Yes. It is a number, constant, 4 multiplied by variable to the positive integer power. Okay? You obey all the rules.
Miss A,
Yeah.
is that what I asked this people?
Yes. I will send it to
Hi,
you.
Henry.
Go Tigers! Yeah, but I send the link to you all if you want to, review. Definition, okay? We have monomial. What is monomial? It's just one term. One term only. So, look at this. This is one term, right? Monomial can be the product of a constant. Constant could be a number. Any real number is okay. Multiplied by variable to the power of the whole number, like 0, 1, 2, 3, 4, 5. Yes? If you have one term, it's called monomial. if you have two terms, it could be adding or subtracting, right? Negative x minus 5 is also two terms. This is called binomial. What about three terms? Trinomial. What about four terms? Polynomial. Yeah, anything beyond three, we just say many terms, okay? When you have many terms adding together, that will be an expression of a polynomial. So let's start from looking at a single term, a monomial. From a monomial, we need to define what is the degree. Okay, when you define a polynomial, we need to know what is the degree, highest degree. And degree is that variable to the power of exponent. So the power, you are bringing y to the power of 3. Okay, so the degree of this term is 3. If I have negative 2x to the power of 5, what is the degree? 5. So look at how many x, right? What if I have more than one variable in that expression? In this example, 7x squared y cubed z to the power 1. We don't need to write z to the power 1, we just write z. But in this case, this term is combination with many different variables, and all the power of variable counts. So you will add only the power of the variable, okay? 2 plus 3 plus 1. So the degree is 6. Degree is 6. If I have pi, 3 pi a squared b cubed c 4. What is the degree? Let's look at all the variables. What are the variables? 3 is a number. What about pi? Is it a number or is it a variable? You know pi since elementary. How big is pi? 3.14. So it is a number. So this is a constant, okay? Don't look at pi as a variable. So the only variable is a. So you're gonna take this power. So 2 plus 3 plus 4. It is 9. Correct. This is a constant only. What is the degree of 12? 0. 0 degree. And it is okay to be a degree 0. It is a polynomial, right? We can write it as 12 times x to the power 0. Because whole number, positive integer, is including 0. So that's fine. The degree of a monomial in the form a is constant, x to the power n, y, n. So you add the exponent to be the degree, and a is called the coefficient. Coefficient. Everybody okay so far? Good. So identify the leading coefficient and degree for the following expression. Actually, leading coefficient, we need to look at many terms. For example, if you have like 3x power 5 minus 11x power 3 plus 2x minus 11. So you have how many terms? 4 terms. What is the highest degree? 5. So this polynomial expression has the highest degree of 5, and that term with the highest degree is called the leading term. Leading term is very important that we can identify that because this expression later on we can graph it. And when you see the graph, the behavior of the graph is going to follow that leading term. This term dominates the behavior when x approaches to infinity, okay? And the leading term, that leading coefficient, the number attached to it, positive or negative, is also important. It changes the ending behavior. Does it go to positive infinity or negative infinity? It all depends on that leading coefficient. Is it positive or is it negative? So that's why we need to look at each term, okay? Let's identify the coefficient. Let's say this is the leading term of polynomial. What is the degree? And what is the leading coefficient? Degree of 4, leading coefficient is 1, right? We don't need to write 1x power 4, so it's 1. Leading coefficient of this 3y squared is 3, and the degree, 2. What is the degree of 2? 0. And the leading coefficient? 2. Good. Continue. What is the degree of this term? 12. And the leading coefficient? 23. What is the leading degree? Sorry, what is the degree? 8. And what is the leading coefficient? 1, 4. Yes, 1, 4 times power 8. Very good. Next one, degree of 8. Leading coefficient? 12. Not so bad, is it? Not so bad. So your next task is to look at a polynomial expression with multiple terms adding, subtracting together. And you know to find the leading term in a polynomial. And how do you find it? Find the highest degree term. That will be the leading term. So monomials are great, but we also care about expression with more than one term. Okay, what is the term when we define a monomial or sum of monomials? The sum of monomial is polynomial, correct? Is the polynomial family. Polynomial. Not Romeo. Polynomials. So we generally want to write polynomial in descending order. So if you have an x power 5 plus x cubed plus 12, you don't want to write 12 plus x cubed plus x power 5. You want to order in the order of highest degree to the lowest degree. So we're going to write it in the descending order. Okay? Oh, sorry, it says descending order. We want to write it in the standard form. That's what I want to say. We want to write this in the standard form. When the polynomial is written in the standard form, it will be in the descending order. Okay? According to their degree. The degree of a polynomial defined as the degree of the leading term. There are many terms, right? find the highest degree term, and that is the leading term. The coefficient of that term with the highest degree is called leading coefficient. So far, so good. So below I have 4 different polynomials. Can you identify the number of terms? What is the degree? What is the leading coefficient? Yeah, I suggest you circle the leading term from each polynomial. Okay, some of you have to kind of add to see it. When you're done with this, touch your head so I know you're done. All right, Chloe, can you get just take us through the number of terms for this 4 polynomial? So the first one, 3 terms, 2 terms, 3, 3. Okay, that's wonderful. Next one, we need to determine the degree. So can we circle the highest degree? Circle the leading terms. Which term it has the highest degree? 23x1. Okay, that's the leading term. So from here, can you tell me the degree of the polynomial?
Is it 6?
Nope.
No, 4.
4.
Yeah.
That leading term is the determination of the degree, not adding all the power of each term. So degree of 4. And what is the leading coefficient?
The leading coefficient is 23.
23. Great. All right. Audrey, can you help me with the second term? Second polynomial expression.
12.
Which term is the leading term?
12
12e squared. And the degree is 2, leading coefficient? 12. Excellent. All right. Savannah. The third polynomial expression. Can we look at each term first? What is the degree of the first term? 8, because we need to add, right, 4 plus 4. And this is degree of 7 and 6. So the leading term is actually that, okay? So what is the degree of this polynomial expression? 8. And what is the leading coefficient? 8 as well. Good. Okay. Now, Audrey, did I already call you? I did? Oh, yeah, we did that one. Patricia, which term is the leading term?
4.
Leading term.
45 due to
Right. This is degree of,
4.
and then leading coefficient 45. Great. Everybody okay? Move on. We can categorize polynomials by the number of terms that they have. You actually know this. So as we saw before, polynomial with 1 term, right, we just introduced, we call monomial. We can is that the polynomial with two terms is called a binomial. Like a bicycle. And with three terms is a trinomial. Anything greater than that is polynomial. So all this expression is called the second degree polynomial. 4x squared, x squared. Oh, x squared minus 9. This is binomial with degree 2. Or this is a trinomial with degree 2. This is a monomial with degree 2. They are all second degree, right, polynomial. Third degree, so when we are defining how many degree is now looking at how many terms, but the highest degree of that polynomial, right? Fourth degree, fifth degree. And we have different names if they're written as in terms of x. Degree 0, okay? Example is like -9, positive 100, square root of 2. When you just have a constant, it's degree 0. This is called the constant. X minus 4, that's degree 1. And that's what we know as linear, right? Mx plus b. So x to the power 1. When you have x squared is quadratic. X cubed, cubit. X power 4, quartic. Degree 5, quintic. So these are the names that you need to understand as well. All right, next. When you have many, many terms grouped together, we always want to simplify by combining the like term. Bananas with bananas, oranges with oranges, apples with apples. Yes. So what are called the like term is the term with the same degree. So can I combine anything? And I want to write it in the standard form. So I want to have the highest degree term goes first. So which term is the highest degree? Muriel? 23 x power 4. Yeah, that's 4 degree. And then I have two like terms with the degree of 3. So add them together. 4 plus 2 is 6. And then x squared term, adding together, 12x squared, only one constant. So this is called the standard form. And what is the degree of the polynomial? 4. And what is the leading coefficient? 23, positive 23. Right. So this is called a quartic. Degree 4. All right, next one is very similar, but involve the property of distribution. Believe or not, up till now, in honors algebra 2, you're still making the mistake of not distribute that negative to every single term. Yeah, a lot of students just, oh, this is plus x power 5 and then plus, you're not changing the sign. So don't make that rookie mistake, okay? Change that. So plus minus 8 minus 4 minus 1. Okay?
Shouldn't it be plus?
Plus 1. Yes. Change sign. Thank you for catching that. Good. Now the standard form, which term is the leading term?
Negative x. Oh,
X power 5. X power 5. Now let's see. We have X power 4, and then combine those. Yeah? 93 minus 8 is 15. X power 4. How many X power 3? Nothing. Okay, X power 2.
Nothing.
X power 2. Cancelled. Great. Love canceling things. And the last term will be constant. Negative 19 plus 1. Great. So this will be a, describe the name. How would you categorize this? We can categorize a polynomial by number of terms or by the degree. So if I want you to categorize this by number of terms, what would you call this? Trinomial. This is a trinomial. And if it's by degree, it's a quintic. Yes. Good. Yeah. That's the identity of this polynomial. Okay, great. So evaluate the function. We already learned this from Unit 2. Right? We can name each function differently. This is G is a function of V. And this is a function in terms of V. So when we evaluate, just replace the V with the number inside. G of 0 is 5, right? 0 plus 5. G of 1, 2 minus 4 plus 5. Wow, this is just too easy. Are you bored? I am. G of negative 2. All the V need to be replaced by negative 2. Carefully evaluate. What is the first term? Big win today. What is it? Negative 16, yes. This is negative times negative become positive. So minus 16 plus 5. Right, so it is negative 12. Okay, this is negative 27. Evaluate polynomial function. That's not new. You know this already. Okie-doke, move on. Told you it's not too hard, right? Now we need to if to add, subtract, multiply, and divide. Ready for this? Notation. You probably know how to add and subtract polynomial with the like terms, but this is the notation you have to understand, right? Math language. If I want you to add f plus g, there are two different polynomials, I can return as parentheses f plus g of x, or f of x plus g of x. If I want to subtract, I can write as f minus g of f of x, or f of x minus g of x. So, given this is f, this is g, and you do the following. This one, because I want to add the two functions, so I will end up with a function expression. Second one, I need to replace the x value with 2. So at the end, I will get the number at the end. So let's try this. 2x cubed minus 3x squared plus 4 to the degree. Plus negative x squared plus, oh, okay, 4x plus minus 9. Oops. Minus 9. So I will end up with, right, you're sitting along x, 2x power 3. Negative 3 minus x is negative 4x squared. A single term of plus 4x. Combine the constant, minus 5. Alright. So this is f of x plus g of x. The second one, you need to reckon that this is g of 2 minus f of 2. So we can actually calculate each part on the side here if you want. Right? So what is g of 2? Substitute into g. Negative 4 plus 8 minus 9. I got negative 5. Please help me if you catch a mistake. Thinking fast. Now I need to figure out what is f of 2. And pick the right function. F of 2 is sub x into f. So 2 times 2 cubed is 8 minus 3 times 4 plus 4. Okay, 16 minus 12 plus 4. It is 8. Okay, we found both. So, g of 2 is negative 5 minus 8. Negative 13. Some student might try to subtract g minus f as a function and substitute 2. That will be okay as well. You're like, wow, this is too easy. Get something harder. Okay, let's multiply. So far it has been a review, isn't it? Didn't you know this already? So when you multiply polynomials, okay, binomial multiplied by binomial, we can use FOIL. First term times first term, right? Outer term times outer term, inner, outer, anyway. So just distribute. Okay, let's practice. The first term needs to multiply each factor in the back. Yeah. So 3x times 4x. Aiden, what is 3x times 4x?
12x squared.
Perfect. 12x squared. And then we're going to do minus 21x. Second term from the first part is going to multiply. Doesn't change color for me. So plus 24x minus 42. So 12x squared. These are the like terms. Combine. Alright. Simple, simple. Since we're dealing with polynomials, right? You have to know when you multiply with the same base, you add the exponent. Yeah? When you multiply with the same base, you add the exponent. For example, 3n cubed times 4n 6. Number times numbers. 12. N to the power of 9. Yeah, 3 plus 6 is 9. So here, 9 times 3 is 27. We can only combine the element with the same base. So this is u squared times u to the power 3 is u to the power of 2 plus 3. Yeah, it's 5. Good. And finally, we have n. n to the power of, this is 3 and negative 2, 1. Good. It's 1. I don't need to write it. Okay, on the right. I think you're good at this, so I'm just gonna write down 7 z power 4. That's funny. What is x to the power 0? What's anything to the power 0? Anything to the power 0 is 1. So a to the power 0 is 1. Okay, since we're here, when you multiply with the same base, you add. What about when you divide? A to the power m divided by a to the power n. You subtract m minus n. What if I have power to the power? So a to the power of 5 to the power of 3. Anybody know what this is? Power to the power. A to the power of, what is it? 15. Yes. Power to the power, you multiply. Yeah. Okay, so we know this is 1. This is 1. So that is 12 x 5 y squared. Multiply. Okay. Binomial multiplied by trinomial. So when you expand, you're gonna have, right, 6 terms. So I already write this down for you, so we just need to evaluate this. 3 times 2 is 6, x power 5 plus 3x cubed plus 3 times 4 3x cubed plus 12 squared plus, what's that? Benji? And 4, good. That is 5x squared plus 1tx. Now, apple with apple and banana with bananas. Write it in the descending order from the highest degree to the lowest. We got the highest degree of, do we have a 4? Degree 4? Okay, so no, and x power 4. Degree 3, oh, only 1. Degree 2, right, we have 2 of them. Add them together. Finally, what is the leading coefficient?
6.
What is the degree of the polynomial? That's good. So far, so good. Yes. Your turn. I want you to do this second and the third one. All right, so I'm gonna pause. I'm gonna do it. Okay. There are special type of polynomials like this. So it's called the difference of square. Have you done this before? Yeah, I bet you do. So when you multiply two binomial like this, a minus b times a plus b, this is actually called conjugate. Conjugate, okay? One is a minus b, one is a plus b. So let's see what happens when we expand. If you forgot the formula, okay, don't just blindly try to memorize it. This is actually going by FOIL. So a squared plus ab subtract ab. You see the middle term cancels? And then plus b squared. That's why you end up with the difference of square. What does that mean, difference of square? Difference means subtract. And the first term is a perfect square. The second term is a perfect square. Yes.
So when you expand that, it will be that.
I wouldn't say expand. I will say factor.
Okay.
Yeah, usually we say, can you factor the difference of square, right? So the question, if I say expand and simplify, that's after you expand and simplify. That's a factor, you need to multiply by the factor.
So
So
it wouldn't be parentheses a minus b times parentheses a
Yes.
minus b. It will be that.
right, so we're gonna practice both. So here we will say, can you tell me the expression after you expand and simplify? You can recognize this, right? A plus b, a minus b, so that's x squared minus 2 squared. Yeah? And here, if I say, can you factor x squared minus 4? If you see the first term is base a is the base, so it's x squared, and then 4 is a perfect square, which is 2 squared. So this should be x plus 2, x minus 2. Doesn't matter which one is first. See it? Expand and simplify. You can take your time to expand, every single term by FOIL, but now you know the pattern, right? So we have a shortcut. We love shortcuts. So what is that gonna be? A squared, right, minus b squared. And what's your a? What's your b? Yeah. So what is 2x all over square? Yeah, make sure you distribute that exponent to every single number. Minus 9. Difference of perfect square, you should be able to factor back. Now, is this the pattern of difference of square? Right, this is perfect square, so 5 squared. And what is the base of x squared, right? So it's gonna be 5 plus x squared times 5 minus x squared. Everybody okay with this? Move on. 等一下。Since this class is so great, let me give you a bonus question. A bonus question, yes. Can you factor x power 4 minus see another difference of square.
Oh, yeah. X minus 2.
Aha.
Minus 2x plus 2.
So,
Easy.
X minus 2, x
so
plus 2,
proud
x
of
minus
you.
6 plus 2.
this
X
is
plus
x
2
plus
squared.
2. Who said that? X plus 2, x minus, not square.
P squared.
I'm recording.
The one on the right.
No, he is talking about this one. Are you talking about this one?
Oh.
Yeah.
Andrew, 都比我笨。
No.
Why
Hey.
Oh,
Hey, you guys, watch yourself. You're gonna make that mistake, okay? When I catch it, it's gonna me. I make that mistake. Okay, so this cannot be factored further. This is not difference of square, all right? And this is not the perfect square trinomial type. So this stays.
Oh.
Wait, can't you make that one x plus 2 and then x minus 2?
What is the pattern? It needs to be difference, not sum.
Oh.
Difference.
So you have x plus 2 times x plus 2?
Yeah.
X. 什么？
Like the x squared plus 4. Can that be x plus 2 squared?
See, that's the same mistake as Andrew. That is.
Sophia, let's listen that. Let's listen that. She
Let me show you what is that mean. Okay? Now you're laughing, but you're gonna make the same mistake.
No, I don't
so
like
is
that.
that
Blaming that.
equivalent to
negative.
x plus 2 squared? Let's look at this. This is x plus 2 times x plus 2.
Yeah.
Is
Wait, no,
that
can you?
Oh no.
Retract your statement,
It's
please.
oh, two different. Oh my god.
x squared plus 2x
老师，我了解了。
plus 2x?
Am I right? Really?
Too much.
Am I right? Okay. Wait, so can I?
Are they equivalent?
No.
Sure.
I
You
forgot.
never
Sure.
So this is what I'm introduce this.
Yeah.
This is called perfect square trinomial. Okay? You have a trinomial that can turn that into binomial square. A plus b all over square or a minus b all over square. Only when it's a trinomial like this. Alright? Yes.
So does this work?
No,
Why not?
this is equal to x plus 2 times x plus 2. This is still x plus 2 over square. That's not x squared plus 4. Okay?
Why not?
I'm going to go over, just sit down and watch. Why not?
Why is this so confusing?
Like I said, if you're not sure, expand. Expand, you will know why. So a plus b all over square is not a squared plus b squared. We can take our time to expand, right? That is a plus b times a plus b.
Where's the
It is a squared plus ab plus ab plus b squared. You are forgetting the middle term.
Oh. Okay, I see.
Yeah, you see.
Andrew 笑我。
Right? If this is subtraction, then the middle term, 2ab will be minus 2ab. Okay? So, when I give you a binomial, can we recognize is it a perfect square trinomial? Right now, we are going to call this PST. When we say PST, you know this is represent perfect square trinomial. Okay? So, like this. If I have x squared minus 10x plus 25, is that a perfect square trinomial?
Yeah.
Okay, look at the first term. Is that perfect square?
Yeah.
That's x squared.
X minus 5.
5, right? the middle one has to be 2ab. 2ab is 2 times 5 times 10x, that's great. Since this is minus,
It's also minus.
this is also minus.
Oh.
Yeah. Yes, yes. Okay, so first, examine the first and last term. Are they perfect square? Second, once you find the base a and b, multiply and times 2. See if the middle term is 2ab.
Wait, why is it minus 5?
Because when you expand, right, when you do inner outer,
Oh, it's because
isn't it minus ab?
Oh, I got
minus-
it. It's because 10 is everything.
Ah, good. Okay, next, let's identify each trinomial. Is it or is it not PST? What does it stand for? Perfect square trinomial.
Poo-poo.
Are they perfect square trinomial?
No.
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 No. Okay,
I know, right?
look at, be careful. Be careful. The first step when you're trying to factor is actually pull out the least common factor. So sometimes the perfect square trinomial is hidden. So what can I factor out?
2.
So you do the factor first.
I guess
X squared plus x plus 1. Oh, look at that. Now, the first and last term are actually perfect square, right? So this is a squared. A is x, b is 1. Check the middle term. Is that 2ab?
No.
No, so this is not.
No.
Okay? Here, can we factor?
No.
Yes?
Yes.
What is the common factor between the three?
2.
Oh, actually factor doesn't help.
Yeah.
Is it still not factorable?
5z plus 2. Yeah, this is not perfect square. So if you start from here, this is, what is the perfect square here? 2z, and then this is 2, and then this is not 2ab. Doesn't match. Okay, so this is,
So I told you.
Right or what?
Right? No.
is it?
Yes.
Yes.
What is the perfect square, the base?
4w squared.
4wx,
Squared.
4 W
Square.
Five.
5 square. AB times 2?
Is 40w squared.
Perfect. Perfect. So what do you write it?
4w squared plus 5.
A plus B, right? This is addition. 4w squared plus 5 all over square.
How do you tell if they're a perfect square?
Sophie.
混的。
Wait, how do you tell if they're a perfect
We just said, okay, so you first look at the first term, last term, are they perfect square? They
Yeah.
are perfect square. So now you need to look at the middle term.
Yes.
Is this 2ab,
Oh,
right?
okay.
So 2ab will be equal to 2 times 4w squared times 5. So that's 40.
Wait, how? 可是4乘5不是
4 times 5 times 2.
4乘5是
That's AB.
Oh.
Is it?
Yeah.
What is it?
Oh my god.
9u cubed.
9u
Q.
cube
6.
2u.
2U.
plus or minus
Minus.
2u.
Q.
Actually, you know what?
What?
I know what.
This one is not completely factored. This is a perfect square trinomial, but what can you factor out here?
Oh, you can do the thing.
They all
U
have
squared.
u squared.
Wow, so smart.
81
Yes,
u4
Andrew, we have smart.
But this A,
36
can we keep going? Like, can we keep like factoring like the thing that we did before, like the perfect?
only when that's difference of square. It's already done here. So
Oh,
here,
okay,
you
the difference is
can
right there.
actually take out the u square. It's actually 9u squared plus 2. Okay, I need to move on. Division.
什么？还有？
Polynomial divided by
老师，
a single term.
There's too much.
老师，you have 4 minutes.
Yes, I can do this.
No, I can't. I can't.
Greatest.
Bonus A.
Okay, if I want to divide,
It's the equivalent of minusing W. From
Minusing?
so,
It works. Minusing, guys.
like I said, this is the common denominator. So, a lot of you will do this. Oh, yes. Done. It's not done. You
No.
only do the first term. That is wrong. Do not do that.
You do all three of them.
Yeah, you do it.
Mr. Hicks, 叫我听他讲话。
Okay. So remember, this is common denominator. So every single term need to divide it by W.
I hate that word.
Now you can divide, right? 16W cubed plus 40, 2 minus 1 is W. We are gonna keep this as 25 over W.
No.
After I divide, is this still a polynomial family?
No.
No, it's no longer a polynomial family. Because this term, W is in the denominator. All right, let's try this one. 6a squared b squared.
2减2七，
I don't think that's
2减
correct.
没有。
That doesn't look correct.
Every single term divided by 2a squared b squared. Okay. What is the first term after I cancel?
3A. 3.
3. Second term?
2B. 2 over B.
Excellent.
Wow, I'm so good.
Third term?
3 over A.
I haven't done the 2.
Oh, I mean, 3 over 2. 3A. 3 over 2A.
Yeah, so if I write it in the exponential form, this term will be 3 over 2h power negative 1, right? That is not the polynomial. Okay, last term is to look at the common factor. Least common factor, greatest common factor, not least. Greatest common factor, identify. What are the factors they both have?
2. X. Yeah.
Oh, wait,
That's one?
that's LCM, never mind.
64X.
Wait, LCM.
There's no x.
Oh, 64.
Everybody need to have it.
9y,
9y.
12xy.
12XY. 完了卖菜了。
All right. So can we write this in the factor form? What happened when you factor the x out?
7x plus 1.
Yeah, excellent.
Yeah, let's go.
8x squared.
8x squared. Wow. look at me.
8x squared.
I'm on a roll.
Is there
Okay.
3
3x cubed.
Oh my, you
plus
go
x
pick
plus
on
2.
SAQ.
plus?
X plus 2.
我为什么还要改 SAQ 啊？不是 SAQ。
All right. And this is,
5u squared.
can I factor the negative 5
No.
out? Yes, I can.
Oh, but I
After that,
didn't, so you can not.
You?
What is happening? 我放弃了。
Minus 2.
Yeah.
There you go.
Yeah.
All right, so the last one. Okay, I finished. Oh, wait, can you see this, Joe?
Holly got a meal.
Polly got a meal.
Polynomial.
我是绿色的，超丑。
Why'd you choose it?
别人上我的。
Okay, great.
5谁？